Hi, I'm Expedition 2021 astronaut Bob Thirsk, and I'm speaking to you from the Columbus Laboratory aboard the International Space Station. What's really exciting is that the Space Shuttle Endeavour is currently docked to our station. For the last week and a half, we've been working closely with the STS-127 crew. The shuttle will undock in a couple of days. I'd like to talk to you about the immune system in spaceflight, and also about one of the experiments on board our expedition called integrated immune. The immune system is one of the largest tissues in our body. Basically, it consists of circulating white blood cells in the lymph nodes of our body and throughout our bloodstream. It protects us against viral and bacterial infections, against reactivation of latent viruses like cold sores, and it even can protect us and stand on guard against malignancies as well. But the thing is that in spaceflight, the immune system does not operate normally. We first discovered this back in the late 1960s and the early 1970s. Half of the Apollo astronauts experienced bacterial or viral infections during their flight or shortly after they got back home. Scientists then studied subsequent missions and subsequent astronauts who flew and found that, sure enough, there was some irregularities in the immune system. Well, what we do know is that there seems to be a redistribution of white blood cells in our body during spaceflight, and some of the other defensive cells and the other immunological factors also seem to be distributed differently and function differently in a weightless environment. Well, we do know that immediately prior to flight, immediately after flight, that we're probably subjected to physiological stresses at these difficult times of our career, and that's probably responsible for some of the immunological dysregulation at these times. During flight, some of the causes of immune dysregulation or dysfunction could be altered circadian rhythms in space. It could be the weightlessness itself. We don't know the effect of ionizing radiation on the human body. We also know that there's a couple of substances, glucocorticoids and catecholamines, which are elevated in our bloodstream. Perhaps these elevated levels of these substances are causing derangements in our immune system as well. Well, what are the repercussions of an immune system that's not operating perfectly in spaceflight? Well, hypersensitivities, allergies, autoimmunity, even malignancies could be the consequences many years after of an immune system that doesn't work properly during a long-duration spaceflight. Well, what does the Space Shuttle Endeavour have to do with all of this? Well, tomorrow will be the last full day that the Endeavour and her crew are docked to the station. We know an awful lot about the immune system immediately before flight and immediately after flight, but we don't know a whole lot about the immune system during flight, especially long-duration flight. And the best way to learn about this is to take in-flight samples. So, during this week, and especially tomorrow, we will be taking dry saliva samples, we'll be taking wet saliva samples, and we'll even be taking blood samples and returning it on the Space Shuttle Endeavour to the scientists associated with the integrated immune experiment. Speaking of scientists, the lead scientists for the integrated immune experiment are Drs. Brian Crucian and Dr. Clarence Sams. And they will analyze the results and provide us feedback and hopefully countermeasures in the future that will prevent immunologically related disease. Infections are the things that we worry about the most. We do take some countermeasures right now. Before we fly, the hematological and immunological status of each astronaut is verified to make sure that it is at least equal to that of control subjects on the ground. And also 1 week before we launch, a quarantine period is instituted, which protects us from catching communicable diseases. So that's a capsule summary of the immune system in spaceflight, and a little bit about the integrated immune experiment. It will provide us with important information about the status of the immune system during flight, especially long duration flight, any physiological stresses that we're exposed to, and perhaps they can come up with some new countermeasures that will protect us. The good news is that no infectious incident during flight has ever impacted the objectives of a mission. But our long-term future is on the moon and on Mars, and we've got to find out more precisely what the immune system is all about during spaceflight before we send astronauts off on these very long-duration missions. So long from the International Space Station. I got to start donating some samples here.